Hey everybody, I'm going to check out the spectral purity of the old K3 here. We're sitting on 40 meters. I got it set for 100 watts. Here's a 100 watt attenuator I just picked up pretty reasonable off of eBay. And over here is a little step attenuator that's good for 1 watt. So I put 100 watts in here, and that reduces the power level quite significantly to 100 milliwatts, which is fine for this little step attenuator. This is 30 dB. Over here I've got it set for 40, and all that goes into the TinySA. So let me get this set up and we'll run a quick scan. Okay, here we go. I hope this shows up. If it doesn't, we'll do it again. Alright, so I'm going to go into transmit now. There's 100 watts out, and I'll do a quick single scan here with the TinySA and turn the transmitter off. And you can see, I hope anyway, the fundamental here at 7210 is minus 19.5 dB. So for simplicity's sake, we'll call it minus 20 dBm. And we'll look at the harmonic content here. First one I want to find is the second harmonic down here at 14. And there it is, which is according to the TinySA here, minus 88 dBm. So let me write that down here, minus 88, and then we started off with minus 20, so that's 68 dB down at the second harmonic. Now the third harmonic is always going to be a little bit bigger, and that looks to be, call it minus 78. Minus 78 dBm, and we started out with minus 20, so that's 58 dB down, which of course exceeds the spec. And way over here we got the fourth harmonic. Yeah, that's the fourth harmonic right there, which is at minus 93. Let me write that down, minus 93. So that's about 73 dB down for the fourth harmonic. Now let me just go into the continuous scan mode here. And I'll go back into transmit. And there we go. Pretty cool. Turn the transmitter off. I've got the TinySA set up for 2,000 points per scan, and I'm scanning from 6 to 50 megahertz just to capture the second, third, and fourth harmonic on for 40 meters. Okay, so a quick rundown of what's happening here. Sorry for the camera shake. Coming in here is the K3, 100 watts input here. This is a 100 watt 30 dB attenuator. So if I put 100 watts in, that's plus 50 dBm. Minus 30 dB gives me plus 20 dBm coming out of here, which correlates to 100 milliwatts. So 100 watts in, 100 milliwatts out with a 30 dB attenuator. And then that goes into one section of an HP step attenuator here in 10 dB increments, and I've got it set for 40. So coming in here, I've got plus 20 dBm minus 40 dB here gives me minus 20 dBm into the TinySA. And the maximum input for the TinySA is plus 10 dBm, or 10 milliwatts, according to the handy little signal level conversion from the experts in frequency. So there you go. 100 watts. The output is 100 milliwatts. The output here into the TinySA is 10 microwatts. So we're going from 100 watts to 10 microwatts. Anyway, I got this, just got this 100 watt 30 dB attenuator off eBay for a pretty reasonable price. Now the next thing I want to do is maybe look at a couple different other transmitters, including the old, whoops, kind of messy in here today. I compare the T4XB with the K3. I'll look at the K2. Got a couple other little transmitters here, but now I can mess around with up to 100 watts. So that's just another use for the little TinySA. What a little gadget that is, boy. I mean, it's got limitations, that's for sure. But for $55 or whatever they cost, pretty nice little gadget to have in the shack. Now you can also look at modulation and so forth, but there's where it kind of falls down a little bit due to the, I'll have to tinker with some of the settings, but the reverse bandwidth, or the resolution bandwidth, may not be sufficient to give a good display of actual modulation. I don't know, I haven't tried it. Anyway, good tinkering. See y'all later.